Howdy everybody, howdy everybody. Hi, we're going to learn about this here. You can pause the video, you can take a look at it for a second. We're in module 3, which, in computer concepts, it's some great stuff. And this is a really important lecture. I wanted to make sure I said that because you're going to learn some concepts in this lecture which are going to help you in everyday life, no matter what you're doing. And particularly when you go to purchase a computer, it's going to help you understand what are you looking for? How many gigahertz do you need? What's the difference between Intel and AMD? How much memory or how much RAM do you need? What kind of a solid state drive do you need? Do you need a solid state drive or a hard disk drive or both, and how big? So you're going to learn about those things in this lecture. And if you remember in the previous lecture, we went over these things right here. We learned about how computers work and that they run on electricity, and electricity can be in two states of on and off. And a computer is kind of like your porch light on Halloween in that you have a light switch, and if you turn that light switch on, it means one thing, and if you turn it off, it means something else. On Halloween, the light switch on your porch, when it's on, it means, so on Halloween, computers are like your porch light on Halloween. And when your porch light is on Halloween, when you flip that light switch to on, that means come trick or treat. And if you flip that light switch to off, that means go away. And so these are known as coding schemes. And depending upon whether or not a switch or a circuit is in an on-off state, we could have that be, have that represent, the on-off state can represent some piece of information. And so it could be come trick or treat or go away, like the light on your porch on Halloween, or it could be the letter A, or it could be a sound, or it could be the color of some pixel, a picture element on your screen. So this image that you're seeing here of me recording this video, this is just made up of a bunch of little dots, certain colors. Or it could be the sound, right? It could be the sound you're hearing. So there's 44,100 samples in CD quality sound every second. And it's basically taking little snapshots of what is that exact sound, that exact pitch right there at that one fraction of a second, 44,100 times a second, and storing that with circuits or switches and on-off states. And so those little circuits or switches and on-off states, we represent them as 0 and 1. And 0 represents off and 1 represents on, which is why the power symbol, and I know this is all review, but repetition is the mother of mastery and practice leads to progress. But this is why the power symbol looks like this. It's a 0, which means off, and a 1, which means on. So this is how you turn things on or off. And literally that is 0 off, 1 on. And so that's that. And we call those zeros and ones, right? Instead of saying on and off, we have the on-off states be represented by 1 and 0. 1 is on, 0 is off. And we call those binary digits. We abbreviate those binary digits as bits, just like that. And then we learned how to measure bits. We learned about bits and bytes and kilobytes and megabytes and gigabytes and terabytes. And we learned about 2 to the power of n. So if you have one light switch, if n is 1, you have 2 possible combinations, on and off. If you have 2 light switches, if n is 2, you have 2 times 2, 2 to the power of 2 possible combinations. You have on, you have off, you have 1 on, 1 off, and then you have the exact opposite. And so this is like the number of light switches or circuits that you have. And this is just 2. There are 2 different states they could be in. So when you multiply 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, you start to get numbers which sound like computer numbers. 64 gigabytes of RAM of memory, 32 gigabytes of memory, right? These are numbers that when you go to buy a computer, you see those numbers. And that's because of this relationship here. We're talking about how many switches or how many circuits there are, and those are all, and how many possible coding schemes there are. So it's all related to this idea that a switch can be in an on-off state, and those are binary digits. That's the representation. So that's like what we learned last week. We learned that stuff, and then we also learned the 4 basic functions of a computer: IPOS, input, processing, output, and storage. And a good thing to remember is why why do computers need to do all those things? And you could think about like how your own mind works. And so if I was to give you this problem here, you're going to use all those. So if I said 2 plus 17 equals, you probably just did that math and came up with 19. But to do all that, you had to receive input, right? And you had to store the input as I was giving it to you. So I gave you 2, you stored it in your memory. And then I gave you a plus, you stored it in your memory. And then I gave you 17 and you stored it in your memory. And then I gave you equals and that executed that in your brain, meaning that you calculated the solution to that problem, you processed it, and you got 19. And then maybe you know, if we were in person, you would have said 19 and you would have provided output. And so really, you know, this is what the human mind does right here, and it's also what we ask computers to do, to receive input, to store input, to process input and take data and turn it into information, and then to produce output so that we could see what is the result of that processing. So that's what computers do. And we just talked about, you know, doing that problem, the importance of memory. And so just to think about this from a metaphysical or ontological level for a second, and I love the words metaphysics and ontology, because when you know these words, you know, it empowers you just to not be intimidated by big words, because these are big words and they're big concepts, but they're simple. And so metaphysics is the branch of philosophy that deals with first principles of things, including abstract concepts such as being, knowing, substance, cause, identity, time, and space. And so when we were just talking here a moment ago about something, there's my statistics, we were talking about storage and memory and the way the brain works. And we have to have memory to be able to function. And if we didn't have memory, that'd be really a weird way of being. We're going to talk about that in a second, but this is metaphysics. This is the branch of philosophy dealing with being and knowing, right? And maybe even time and space. Like maybe that's connected to us remembering stuff, because if you can't remember things, is there really time? Is there really time? I would say there's no time. I would tell you there's no time. That time is an illusion. It's an intellectual construct that we've created. And then while we have memories of the past and while we have memories of the past and speculations about the future, there's really only what's happening right now. And why we have this intellectual construct to represent how the present moment is always unfolding into the next moment. And we, you know, have ways to sort of measure how quickly that is occurring. Really, all of that is just an intellectual construct. And all there is really is like this right here, the present moment. And so time is like, you know, is there really time, or is that just an intellectual construct? And all there is what is happening right now. And time is a way that on top of reality, we have these abstractions which are thought to kind of measure like, you know, the passage of the present moment continuing to unfold and unfurling forward like a wave, which we're always riding. So it's really interesting stuff. So that's metaphysics, and it's the branch of philosophy dealing with first principles such as being and knowing and time and space. And then ontology, which is another really cool word, is the branch of metaphysics dealing with the nature of being. And so we're talking about metaphysics here. We're talking about ontology, and those are big words, and you know, they're actually pretty simple concepts. Like if we were just to say this in normal terms and not academize it, that I just made that up. I don't know if that's a real word, but not to make it highfalutin and overly complicated. But if we just say, hey, we're just talking about life, right? Like that's the country cowboy way to kind of say that. We're just talking about life here. Like what's it mean to be alive? How do we think? Like how do we even know stuff? What is consciousness, right? Now we're talking about, and you know, in philosophy, we would say this is metaphysics. It's about being and knowing, and you know, in the ontology, which is the nature of being. And so here, when we start to talk about storage, right, and this is like how computers work, it's also how the mind works. We receive input, we store stuff, we process it, we produce output. So what the mind does, it's what computers do. And in here, when we talk about storage, like it'd be really hard to exist in this world if we didn't have memory as humans. Because without memory, if you just do that thought exercise right here, you would know nothing. You'd be like a baby who's just born. You'd be like, what am I doing here? You wouldn't even know that this was your hand. This hand would just be moving in front of you, and you'd be like, I have no idea what this is. And you wouldn't know that you were a self. like you just be a blank slate, a tabula rasa. And so that tabula rasa is this concept in philosophy from John Locke. And if we go here, and I just think that ChatGPT is just way superior at explaining stuff. So if we go here and say, tell me about tabula rasa and John Locke, and I like being polite to the machine, please. And then also trying to use pretty good punctuation. I didn't capitalize John Locke, but that's right. So tabula rasa is this philosophical concept that means blank slate in Latin. And, I guess rasa is blank and slate is like a tablet, tabula. And the idea that, well, you can pause the video. It's the idea that individuals are born without built-in mental content and that all knowledge comes from experience and perception. So that's incorrect, by the way. So we're all born with genetic knowledge that's passed down to us through our lineage. And that genetic knowledge is autonomous, and it's also stuff that we could consciously know. And so, in psychology, that's referred to as nature. You're born with something, and that's part of what makes up who you are. And then there's also nurture, and that's the influence you get from your environment, your family, the larger ecosystem into which you're born. Your influence, your personality comes out of both your nature, what you're born with, and then also your nurture. Now that nurture can affect you. I'm going into psychology here for a minute. That nurture can affect you. It can affect you. And it does, right? It definitely influences who you are. So in that way, the environment does write upon us. And, as if we are a tablet, but we're not a blank tablet when we're born. And it writes upon us and helps shape our personality. But yeah, so this idea, right, that if we didn't have storage, it'd be really weird. If we didn't have memory as humans, it'd be really weird. And what I'm just trying to reinforce here to draw this back to our computer class is the importance of these 4 functions, both in how we work as humans and also how computers work. And not only the importance of these 4 functions, but in particular, the importance of that function right there, which is memory or storage. You could call it either one. And they actually, both those words have distinct meanings. We're going to learn the difference between those distinct meanings in a moment. But, without memory, without storage, individually, we wouldn't really function. We'd just be like, I don't know what's going on. I don't even know. I don't even know enough to know that a moment ago I didn't know what was going on. Right? I don't know my name. I don't know this is my hand. I don't know, that this is a room. Like, I just have no memory. I don't remember anything. Like, there's no context for anything that's happening. And it's truly as if maybe what it's like when we're just originally born. We're like, what is this trippy existence? What is it? And so we need memory for our minds to work, and computers need some memory, some storage for their mechanical brains to work, so to speak. For them to work, computers need memory and storage, because when we give them input, they got to store it. When they process and get a result, they got to store it. When they're processing, they got to store it, and then they produce output. So we need storage, we need memory in our brains, and we also need that in computers. And this is what this diagram is here. So I call this diagram computer remembering, and I call it computer remembering for a reason. And the reason I call it computer remembering is because memory has a very distinct memory has a very distinct meaning in computers, and storage has a very distinct meaning in computers. And so we're going to learn about these parts right now, okay? And the main kind of context that we're learning about this in is this context of the importance of computers remembering stuff. For them to be able to operate well, they have to remember stuff. And so inside a computer, if you open it up, there's something called the motherboard. And the motherboard is a big circuit board, and this is what it looks like. So the motherboard is a big circuit board inside a computer. And so, here's what it looks like. And you can see there's like little slots, like you could plug stuff into there, and you can plug stuff into here. And then this is where like the CPU would go. And there's all these little circuits attached to the motherboard. And then there's wires connecting all these different mechanical, electrical pieces, the CPU, these different things where stuff has been plugged in that, provide functionality. And so there's wires on this motherboard connecting everything from one piece to another. And so if you look inside a computer, so it looks like this is a case. Nope, just a motherboard. So here's a case. So this motherboard would go inside this case. Now this is not a laptop, it's a desktop, it's a case, and so that's what it looks like in a desktop. That would go in there, and it would have ports on one side, and so the ports would be things that you could plug into. So here you could see you could plug in some USB cables, Ethernet cables, some speaker wires, speaker cables right here for speakers. Keyboards would go into here. Those are old ports. Keyboards today are all USB. Here's some more USB ports, but those are the ports. So you put this motherboard in, it has ports that you can plug stuff into, and then you can connect other stuff to it. And so here you could plug in, I don't know, maybe you'd plug in a graphics card into those, and here you'd plug in something called, you'd plug in memory, or you plug in RAM. It's called random access memory. And then here your CPU would go right here, which is the central processing unit. And so that's the motherboard in a computer. And just like in a family, if you have the mother holds everybody together in a family. If you have a good mother, a functional mother, she helps hold the entire family together and connect everybody in the family. In a computer, the motherboard connects everything in the computer. And so all the different components of the computer plug into the motherboard. They plug in all these different slots, and there's other little places where things plug in, and it connects everything. So you could remember stuff in your memory, which would be plugged into those slots, and then it's all connected by these little wires, these fine little wires just built into the motherboard here, the circuit board, and those wires are called buses. And so they're not like buses that you see driving around in the city, but that's maybe why they got their name, because data could get on the bus and go from one place to another, but they're just wires. And so they're wires that allow data to go from here to here to get processed, and then once it's processed and the results achieved, to go back to here. And that's what a motherboard does, and that's the beginning of understanding how computers work, is the motherboard connects all these components. So now we're talking about computer remembering. Remember? We're talking about computer remembering. And so what we have diagrammed here are the different components that computers use on in their systems, in the machine, which is a computer. These are the different components where computer remembering occurs, where computers remember stuff. And here we have the CPU, which basically you could think of that as the brains of the computer. It's the central processing units where all the processing occurs. And as you get closer to the CPU, the locations where things can be remembered can store less, so you can store less, but you can access them faster. So there's some areas right on the CPU and right next to the CPU where the CPU can remember stuff. And so those areas are registers. So registers are right in a CPU. And when the CPU is processing stuff, it could store little pieces of data in those registers. And if we were doing that problem, it'd store the 2, it'd store the plus, it'd store the 17, and then to execute, get 19, and store that result. And that might all be being stored in registers as it's doing that processing. And then there's also cache. And cache is a place where it's right before it's used for registers is like while it's processing, it's using the registers. And cache is like information that is ready to be pulled in for the processing. It's like it's right here if you need it. But both of these places are the two places of computer remembering where they're the smallest, so the least amount could be stored there, but they're the closest to the CPU. And in fact, they're both right there built into the CPU. And with caches, there's L1 cache, L2 cache, and L3 cache, level 1, level 2, and level 3. And level 2 and level 3 might be just outside the CPU. But both of these areas here, registers and cache, they're the smallest places of computer remembering, meaning you could store the least there. But it's the place where the CPU has the fastest access to that. And so as you go from like closest to the CPU, you store less and you can access it farther. And as you go further away from the CPU, all the way out here to things like your hard disk drive or your solid state drive, we're going to learn about those in a second. But as you get further away from the CPU, you could store more. You could store an unlimited amount. You just have to add more hard disk drives or solid state drives. And you could store as much as Google. But the access to it, if you added that much storage, but the access to it, even though you could store more, the access to it is slower, so it's farther away from the CPU. So I kind of think about the CPU as kind of like, I use a little farm analogy here. So if this is my garage, like maybe this is my whole house, the motherboard, and this is my garage, like this is my workbench, and I could store a little bit of stuff on my workbench, but out here at my barn, which is way out here, I could store a whole bunch more. But you know, when I'm working, the things I'm working with, I'm going to keep them right on my workbench, right by where I'm working in the garage. But if there's something else I need, well, I could go get it out at the barn where I could store more. But to access all that stuff out of the barn, man, that's going to take me a minute. It's going to be slower. So I'm going to have to walk out there, get the exact screwdriver that I need, walk all the way back. It's going to take some time. My processing speed for getting my project done in this analogy, where this is my garage with workbenches, my processing speed is going to be slowed down tremendously if I got to walk all the way out to the barn, get a certain screwdriver, and walk all the way back. It's much faster for me to process and get a job done if I have all the things I need right here on my workbenches, my registers, and my cache, so to speak, right? And so that analogy is like exactly how it works here in the computer. So as you get closer to the CPU, you could store less, but you could access it faster. And as you get further away from the CPU, you could store more, but the access is going to be slower. So those are two areas of computer remembering. They're right next to the CPU, or right on the CPU, or right next to the CPU. Another area of computer remembering is called RAM. And RAM stands for Random Access Memory. And so we could go here to ChatGPT and we could say, please explain to me what is random access memory? And we'll put here RAM. There we go. And so ChatGPT is going to come up with an answer, and we'll let that go. But random access, and we'll come back and look at it in a second. But random access memory is just another location of computer remembering. And now, because it's a little bit further away from the CPU, you could store more, but the access is going to be just a little bit slower. It's still going to be lightning quick because RAM is right here on the motherboard, and it's going to be stored right here in the slots, and there's the CPU. So the registers and the cache are going to be right here, and you know that could hold so much. But over here, you could see like these are big. These are big, and you could have 4 sticks of RAM right here that could be plugged in, and so you could have a lot more storage right here, and it's not that far. But that is still a lot closer than if we had to go all the way over to like, I don't know where your hard drive would connect here, or your solid state drive. But if we had to go all the way here and then follow a cable all the way out to a hard drive, basically going out to the barn, right, that's going to be a lot slower. But this is where RAM would go. It's random access memory. It's called, let me show you what it looks like first. So here's RAM, picture of RAM. And now I'm getting RAM truck, so I got to type in RAM memory. And so here's what RAM memory looks like. It looks like these sticks. And you can see on these sticks, it has little chips. And those chips are silicon wafers. And we looked at silicon wafers in the previous module, module 2. And these silicon wafers here are, each one of these is a little chip. And on each chip, we looked at how many transistors or circuits or switches, call it what you will. We saw how many transistor circuits or switches on each chip. And so if we do wiki transistor count, right, we saw how many circuits or switches can be stored on each chip. And the number today is, I'm just looking there, see if it was right up there. Transistor count is all the way up to like 50, this is million, 50 billion on each one of these little, so it's not the whole circle, but you cut out each one of these squares, and that's a little chip. And that's like the size of your thumbnail, and you could store 50 billion circuits in on-off states. And so when you look at RAM, each one of these has like maybe 1 or 2, or this is all a chip right here with 50 billion circuits that could be in on-off states. And you could get 4 of those sticks, and you can see here, put them into those little slots on the motherboard. And so just so you can see that motherboard again, where's that motherboard? Right here, putting them into those little slots on the motherboard. And now those are going to be really close to the CPU, quick to access, and it's going to be a lot more, lot more room to remember stuff than the caches and the registers over here. So that's what RAM looks like. You literally just plug it in. Here's another image of like what RAM looks like, and that one's like a little bit blurry. So it can also look like that. It could look like this. Just looking for a couple of other images. Like there's some RAM right there. I actually have some RAM that wasn't working in this brand. Oh, there's some RAM. I have some RAM that wasn't working in my brand new computer that I'm recording this on. There's some more RAM that's a little bit fancier looking. but this is the way it's traditionally looked throughout time, and now it's getting packaged a little bit different and looking cool. It's looking cool. So we have the CPU with caching registers, and we have RAM, and RAM is known as random access memory. Now, to understand why it's called random access memory, I like remembering, like, this and sharing about this. So back in the day, this is how we listened to music in our cars, and also at home. And these are known as cassette tapes. And people would, like, you'd get like music, you'd buy it on cassette tapes, and like, so here's an image of it, and this is for sale on eBay or Etsy. And you'd go to the music store, and you would, like, just buy a cassette tape, and then you'd be able to put this into your car and you'd play it. And so I'm just checking out some of these different cassette tapes here. Some of these bands I definitely recognize, and some of them I have no idea who they were. And it's really interesting what's happening to music right now. And maybe I'll share more about that later. If I forget, just remind me. And so the reason we call it RAM, random access memory, is because if I got a new cassette, Sticks Greatest Hits. And so let's look at Sticks Greatest Hits playlist, right? And so Sticks Greatest Hits had Lady, Too Much Time on My Hands, Show Me the Way, The Best Times, Babe, Renegade, Lorelei, Foolin' Yourself, Come Sail Away. So let's say I wanted to listen to either Renegade or Come Sail Away. Both of those songs definitely pique an interest for me, and I'm going to have to go listen to them after I record this lecture. But if I wanted to listen to this in my car, I'd put my tape in, and then I'd have to fast forward past song 1, past song 2, past song 3, past song 4, keep fast forwarding past song 5, fast forward past song 6, Fooling Yourself, fast forward past song 7, and finally I'd get to song 8. And that's because all of these songs are on tape, and I have to move the tape sequentially until I get to the song where it's located. So RAM is different, and RAM is just like a CD, and a CD is also random access, right? So here we have a CD, and with a CD, if I want to go to song 8 on a CD, the playhead just goes straight to song 8. It can go to any random location instantly. You don't have to go past everything in sequence and past all of the other stuff sequentially. You just go to any random point, and boom, it starts right there. Song 8. So that's random access. That's random access versus sequential access, which are tapes. And so when you talk about RAM being random access memory, we can access what is in memory by going to any random location instantly. We don't have to sequentially go buy it, go buy all the other stuff. And so that's why it's called RAM, or random access memory. And often it's just referred to as memory. So people say, how much memory do you have in your computer? And they're talking about how much RAM do you have? How much RAM do you have? So the next area of computer remembering I want to tell you about is secondary storage. And over here at secondary storage, this, by the way, is known as primary storage, RAM. That's another way you can refer to it. And one of the characteristics of primary storage is that when you turn your computer off, everything in RAM goes away, right? So that's a characteristic which in computer terminology is known as volatile. It's volatile because if you turn the power off, everything goes away. And that's just what volatile means in computer lingo, in the domain of computers and computer science and tech. Volatile means when you turn the computer off, everything in RAM goes away. That's primary storage. It's volatile. It's also referred to as memory and RAM. Secondary storage is non-volatile. So you turn the power off, and everything in secondary storage is remembered. And so in secondary storage, we have three main categories that compose secondary storage. And those three categories are solid state, magnetic, and optical. And so these are just like optical are CDs and DVDs, right? Like this is secondary storage. You put something on a CD or a DVD, you can put it on your shelf, and it's going to be remembered. No power required, right? But that's like a type of optical. Optical is a type of category of secondary storage where you could, and types of optical storage are CDs and DVDs. Then we have magnetic storage, another category of secondary storage. And magnetic storage would be like hard disk drives. or tape drives. And so just to see what a hard disk drive looks like, we could do a hard disk drive. And here's what a hard disk drive looks like. And these are platters. And there could be multiple platters in there stacked on top of each other. And this read-write head will read the top and the bottom of the platter. And they work by doing little magnetic charges of positive and negative to represent the on-off states that computers run on, the zeros and ones, which is what we use to represent for us the on-off states. And so that is like, that's what a hard disk drive looks like. And these have moving parts, so they're not. This read-write head has to move back and forth. And if you drop your computer, that read-write head could bang against this little platter and potentially cause damage. And so this is a point of fragility for computers, hard disk drives. And so if you have a hard disk drive, you got to treat your computer a little bit more gently. But then we also have, instead of hard disk drives, we have a new type of disk drive, and it's called a solid state drive. And a solid state drive, there we go, solid state drive looks like this. And so basically a solid state drive is like memory, but it's just made to be a solid state drive, and it's built to different parameters. And so here's a 4 terabyte internal solid state drive for $359. So it's built to different parameters to store more at the expense of being as fast as RAM, but it is still lightning fast compared to a hard disk drive. But it's probably not quite as fast as RAM, and that's just my own generalization, right? So I do not have total certainty about everything I just said there. I haven't factually checked that out, but that's my intuition based upon everything I know about computers. Please comment down below if you know differently. All right, so that's like a solid state drive, and a solid state drive falls into this category of solid state. That's another category of secondary storage. You could have solid state drives. You could have a flash drive. Like this is a little flash drive right here, and I could store stuff on that and take it with me. And you could have like a micro SD card or an SD card, and so that's secondary storage. So the last place of computer remembering we have to talk about is ROM. Before we jump into ROM, let's see what ChatGPT generated for memory. And so you could pause the video and you could read this right here to learn a little bit more about memory. And then you could pause the video and you could read this right here. And while we're here, we'll say, are SSDs slower than RAM? Comparing. We'll just leave it at that. And solid state drives are generally slower than RAM, although they are much faster than traditional hard disk drives. Why RAM is faster? RAM's designed to be extremely fast because it's directly connected to the CPU and serves as working memory. It uses volatile memory technology, meaning it stores data temporarily and can access it almost instantaneously. SSDs, on the other hand, so my intuition was correct. SSDs, on the other hand, are non-volatile, which means they retain data even when the power is off, while SSDs are much faster than HDDs because they have no moving parts. They are still slower than RAM because they are designed for long-term storage rather than rapid access. So that's exactly what I was thinking, but I didn't articulate it like that. That was my intuition. But you can pause the video and you could read through the rest of this here, and it's good stuff just to take a look at. All right, so there we have everything except for ROM. And again, we'll come to ChatGPT and we'll say, can you please explain ROM to me and how it is related to BIOS and what BIOS stands for and the role that ROM and BIOS play in booting up the computer. We're going to get a good story here. And so what ROM does is when you first turn on your computer is literally like it doesn't know anything. So if we didn't have ROM here, it would be like the computer knows nothing. And you turn this on and the computer wouldn't even know how to access information out on the solid state drive. And with the power off, everything is stored over here in secondary storage. That's where things are stored. So this is where your operating system is stored. So when you turn your computer on, it needs the operating system, which is stored out here. But the computer can't access this out here because it doesn't know even how to talk to the solid state drive yet, because it knows nothing. Well, the solution to that engineering problem when they created computers was to put a little bit of software to build that software right onto the motherboard. So when you turn the computer on, right on the motherboard, there's some basic input output. And I always thought of that as basic input output software. But we'll look here to see what BIOS is. BIOS stands for Basic Input Output System. And so in my head, I always thought of it as software, but Basic Input Output System. So it's good for me to get that corrected after 25 years. Basic Input Output System. Maybe that's just like, I don't know, maybe that's out there also in other ways. But Basic Input Output System right there, BIOS, is stored on ROM. And BIOS provides the computer with some basic input output software or system so that once BIOS is loaded into RAM, right, and then RAM, the CPU can grab things from RAM, this computer here now has basic input output system software. And it could do basic input output, which means it could get input from the solid state drive out here. Like this here tells the computer how to talk to this out here. So the computer turns on, loads this, figures out in here how to talk to out here, and then it loads this out here over to your RAM right here. And now your operating system, which was stored out here, I'm enjoying this, is now brought over here, and now the operating system is here. Anytime software is running in your computer, it's going to be stored in RAM. That's your working memory. Okay, and so the operating system gets loaded into RAM, and it's able to do that because basic input output system, which is built into the motherboard, provides the computer with basic input output capabilities to be able to talk to the hard drive out here to load the operating system. And so ROM is known as read-only memory, and it's called read-only memory because back in the day when you got your computer, it would come just with this basic input-output system built into it is read-only. And it was actually like you couldn't change it. It was just burned into, it was like software. Software is nothing more than, nothing more than instructions. And instructions are stored, like everything in a computer, in circuits and on-off states. And so ROM, read-only memory, were circuits and on-off states to store the software of BIOS that were just burned in permanently into the hardware. So it's software that was permanently burned into the hardware, and so they called it firmware because it's software burned into hardware. They called it firmware. And so ROM is sometimes referred to as firmware, read-only memory, and that's where BIOS was stored, and that's what gives the computer the ability to talk to things that are out here and get input into the main part of the computer over here and load the operating system into here so that then your entire computer is booting up. They call that process booting up. So in Texas, in the South, there's a phrase, pull yourself up by your bootstraps. And if you pull yourself up by your bootstraps, you get going all on your own. You make it happen all on your own. And that's what computers do, is they get running all on their own. They load this basic input-output system into RAM. They figure out, once they have that, they know how to talk to things out here. They get the operating system off the solid-state drive. They load the operating system into RAM, and now your computer is booted up and it's running Windows 11 or Mac OS or whatever it is, or Android, right? Or iOS if it's your Apple iPhone, right? It's you boot it up and it's doing all that. So this is the same, whether you're on a laptop or a desktop or like a mobile phone, right? Like the same kind of basic functionality is happening in all those different computing devices. So that's what BIOS is, also known as, that's what BIOS is, and it's stored on ROM, which is also known as firmware. Whew, that was a lot. So it seemed like there's something out here I wanted to tell you about, but I think we've got everything. I want to keep that because I'm going to look at it. But I'm just going to flip through these little things here to see that if we've got all of those. And we've talked about all that, and we've seen that there. And that's the motherboard, and RAM would go here, and there's your CPU, and here are your ports where you plug in different things, including your monitors. So your monitor, you put a video card in, maybe right here, and then your your video card would have the ports where you plug in your monitors. So those ports would back up to the back of the computer. And that's really why, how computers do remembering and the different places they remember stuff on a computer. So I'm going to say we're all done with that. Close tabs to the right, keeping sticks open because I want to come back to it. And then the next thing this is what I wanted. So we had ROM and BIOS. And so you should pause this right here and you should read all of this here. So go ahead and do that. And then I'm going to scroll down and you should pause the video again here and read the rest of that, And that's going to tell you about ROM and BIOS. Okay, that's great. You just learned some really good stuff about computers. And we've learned about IPOS. And we'll categorize different things in a computer based upon whether they're an input device like a mouse or a keyboard or a camera or a microphone, getting stuff into the computer, input devices. Or if they're an output device like speakers, like a monitor, like a printer, getting things out of the computer. Or they're a storage device where computer remembering occurs, like any of the things we talked about here. Or they are a processing device, which is just the CPU. So we'll categorize different components of a computer based upon whether they're input, output, processing, or storage devices. And that's what all those slides there show, which we're not going to go through. So we are going to go through chapter 3 here. And this is the textbook presentation. And I'm a little bit tempted to break this up into 2 videos. I've been talking for 40 minutes. That's a long time. So I think I'm going to do that. And in the next video, we'll go through all this. See you in the next video.